Hi, good afternoon. My name is José Escamilla, actually known as Pepe. I come from Tec de Monterrey in Mexico, and I have the pleasure of moderating this exciting panel, diverse panel. I think that we will have fun today also, so I expect you to be pushing your own boundaries during the panel. As a part of this panel also we have Benson from the National Taiwan University that teaches in Coursera a probability course. We also have Rob from Illinois, Urbana-Champaign, that teaches a course about, I will say, VLSI, chip design. And we also have Jack, who teaches a course on creativity innovation in Coursera. So to start, before starting and giving the floor to the panelists, I would like to ask a question for all of us. What is the pedagogy in a MOOC? And I think that this question has no answer, but the components, not the pedagogy, but the components of a standard or vanilla MOOC are these. It's going to be a lot of surprises during the presentation, as you can see. Okay. Yeah. So the standard or vanilla MOOC has videos, quizzes, assignments, and I think that this is more like associated with a transmission mode of knowledge, more like a instructor-based mode. Yes?
Just to stop the noise, it might be useful if you move downstairs to another room.
Ah, okay.
It's laid out and ready. It would just be a case of you all going downstairs. It might be.
You're asking us to go downstairs right now, or?
I'm asking you if you'd like to go downstairs.
Ah, okay, because it will be like that all the time, or?
It might reoccur.
Okay. Well, I don't know what you think. We should stay? Okay, we will stay. Thank you.
I'll see what I can do outside.
Thanks. Okay. So I think that there are other kinds of pedagogy that we can have in a MOOC, and most traditional MOOCs, on my opinion, or what people mostly have seen, is based on a transmission or an instruction-based MOOC, and I think instructor-based MOOC, and I think that it's possible to do more on a construction of knowledge kind of pedagogy and more centered on the student. And to do this other kind of pedagogies, we need other kind of techniques or activities. For instance, we need to have the possibility of doing projects, to have experiential learning that students that learn doing by themselves, inquiry-based learning also, and gamification, why not? In summary, we need MOOCs that engage our students so that they feel that they've been part of the knowledge of what they're creating. These guys here have experimented around this, and that's what we want to share with you. And also part of this talk will be that innovation is about taking risk. If you are not taking risk and you're not willing to fail, then you're not innovating enough. So in order to innovate, you have to take risks, and risk entails failure. We would like this to be also an interactive conversation, so we'll do 5 minutes each presentations, and then at the end we will have the opportunity of sharing, and we would like to discuss what would you like to get out of the panel, so that the questions or comments that you make will be around that. And also to think about what innovative experiences would you like to share with us, what failures would you like to share with us, what risk have you taken, or what risk are you willing to take or thinking on taking. So I give the floor to Rob, who will be presenting right now.
Thanks.
Thanks.
Okay, thanks. So I'm going to talk about this class, which is looks entirely like an acronym, you know, VLSI CAD. So let me start by just explaining what the class is about. Very large scale integrated circuit computer aided design. So I guess the good thing about when your class is entirely an acronym is that it's maybe easy to remember. I did actually look up, it is the #1 hit on Google. In fact, it's 4 of the top 10 hits on Google because people have been pirating the videos, which is very interesting. In words, this is an engineering class. It's a technical class. This is the mathematics and the algorithms used to build the software tools that build modern chips. So to be precise, this is not a course about designing the chips. This is a course about designing the software tool chains that build the chips. So if you hold up your iPhone, and if you had X-ray vision and you looked inside, you'd find a very large system on chip with about 1 billion transistors. Trust me, they're not being designed by hand. They're being designed by very large software tool chains. This course is, how do you build those pieces of software? And so far, over 2 offerings, we've had about 24,000 students doing this. So in my 5 minutes, the 2 problems that I want to talk about are, first, how do you let students experiment with real tools? Even though we're not primarily interested in just using them, still, you have to give students the opportunity to mess around with them and to understand what they do. And the problem in this universe is that commercial tools cost somewhere between $50,000 US dollars and $500,000 US dollars a license. And with 10,000 students, that's just not happening. And then the second problem is, how do you let students build their own tools? And this is not a discipline in which I can tell everybody you will write in this one programming language in this simple portable environment. It's just not the way this world works. So how do I let people use arbitrary platforms and arbitrary languages and so on? So the first solution we had was we built a set of both CAD tool portals and grader portals. And so we took a bunch of tools that were from the open source universe, many of them about 20 years old because they were the tools that predated the modern commercial ecosystem. We put them on modern platforms and we put them out in the Coursera cloud, and we basically built environments where students could write scripts to use the tools, upload these things to the Coursera platform, and then be delivered results in a batch form in a web page. And that's also the manner in which we ended up interacting with students for their software. So I did not prescribe the platform, I did not prescribe the operating system, I did not prescribe the language. I just said, we will provide you with files, text files that describe in human readable form what I want your tool to do. You will provide me back files that tell me what your tool did. We'll load those things up and we'll actually be able to automatically grade them. So we built a complete software ecosystem just running out in the cloud to make this stuff work in a sort of a completely platform neutral kind of a way. And just as one concrete example, this is a tool from the late 1980s. Students will see a window on the Coursera platform. They'll upload their text file. It'll run and it'll be deposited in a private web page on the Coursera platform. So this is all this was all extremely successful. Maybe a little dull, but in terms of making it possible to sort of interact with all of these tools, actually extremely successful. The cool thing we're just starting to do this this second offering of the class is we're actually starting to port legacy tools so that they run completely client-side in the browser. And this is the result of some very new advances in the so-called software compiler business. There are these things called transcompilers. They're also called source-to-source translators. Have now advanced to the point where you can take some legacy, really old, really complicated systems-y kind of code, C, C++, other crazy kinds of languages, and you can translate these things completely automatically into JavaScript, which is the language of modern browsers, right? Which means that if you have some really old code lying around that you've been using in your class for a really long time and you're wondering, how do I make this stuff available? One new opportunity is actually to translate it and to migrate it so that it runs completely in the browser, which means that no matter what platform students are running on, if they have a modern browser that supports HTML5 kinds of commands, they can probably actually run this stuff on their own machine, independent of what that machine is. So this helps you build very interactive tools that have lots of interactive feel that run completely client-side without actually having to mess around with a lot of software yourself. And finally, one of the other things that we did was we ended up building just a lot of the ecosystem to run the class completely directly in the browser itself. So if you are designing tools that lay out integrated circuits in a geometric fashion, you're dealing with tens of thousands of geometric objects, you can't just ask students to sort of draw those things on graph paper, right? You actually have to provide visualization tools. And since you have no idea what platform they're running on, is it a Linux box, is it a Macintosh, is it an IBM, is it an old IBM, is it a new IBM, whatever. The only thing that you can really control, in a sort of a planetary-wide fashion is the browser. And in modern browsers, you can actually do some interesting things. So I'm just going to show you, if I can figure out where the thing is, some visualization tools that were done by my intrepid TA, Nick. So you go to the web page, it says, oh, there's the visualization tool for this thing that arranges logical elements on the surface of the chip. You literally go to the desktop that the student has, you grab a file from a directory, you drag it on the box that says drop here, and it draws it for you, right? All built completely in the browser. And then we're just going to show you a more complicated one. Bam, all done completely client-side in the browser. And then we can go back. And I'm sorry, you can zoom in, you can zoom out, sort of, you can pan, everything that your browser supports naturally, you can do. You can go back to one of the other portals, one of the other visualization portals, and just highlighting it. You click on the link, you go to the desktop, you grab the file, you drop the background file for the chip surface, you drop the foreground file, and suddenly you're in, right? And you can examine, we got flyovers. We're interacting. You can turn certain kinds of visualization stuff on and off. This stuff is completely implemented in the browser. Right, so my two very high-level takeaways from my 5 minutes are, you have to be careful to assume as little as possible about your Courserian students' computing platform. Right, minimalism is your survival strategy. You have to make sure that everybody can do assignments with the most minimal and most basic of platforms. And we saw that over and over again, where students would be comparing how much time their assignments took, and someone in a more advanced computing platform would be running 10 or 50 times faster than someone running on a 5 or a 10-year-old platform. Nevertheless, the person on the older platform was able to complete the assignment because we were careful, right? And the second thing is, increasingly, the browser is your friend. You can actually build and deploy sophisticated kinds of software infrastructures entirely in the browser, which means things can be very portable, very interactive, and it's possible to actually deliver these things in a planetary scale in a relatively straightforward way. Thanks.
Okay.
Talk loud.
Okay. Hello, everyone. My name is Ping Chen, or you can call me Benson. I'm the director of MOOC in National Taiwan University. I'm also a professor in EWE department. And today I want to present to you the ParkMo. This is the first ever multi-student social gaming platform for general MOOC. Okay. And by the way, this is me. If I remove my hairband, I really look like that. Okay. So let me see. Okay. So basically, I developed this system for my probability course, which was launched on August 31st last year. And the system is actually the first ever social gaming platform for MOOC. And because we only have 5 minutes here, if you want to have more clear information about this system, you can go to the Coursera blog. There's an article and a video about the system. Okay. And basically, let me briefly describe what this game is all about. It's a system that allows thousands of students to play together to work on homework problems. So basically, there's a map system. You have thousands of students all on the same map. Different colors represent different players. Okay, so this is the territory of player one. This is the territory of another player. And the goal of the player in this game is to get as many land as possible. Okay, so for this student, if this student wants to occupy this empty land, and then the system will automatically assign a probability problem for the student to solve. And if he solves it correctly, then he gets to occupy that land. Otherwise, the land remains unoccupied. Okay? And also, as the land grows, when the different neighboring countries, they can conquer the lands of each other. Okay? So by conquering the other people's land, you can get more of your territory. Okay? And we also have some system that students can, if they have a lot of land, they will generate a lot of fortune, so they can buy some monsters for their defense purpose. So they can deploy monster on their land. So if somebody else wants to conquer their land, the monster will send out problems for the other student to solve. Okay, but the problem is, as I mentioned earlier this morning, that my team consists of all EE student and computer science student. We didn't have any student from Department of Economy. And it ends up, our system has a problem because originally we thought that every student probably only spend will have time to solve like 6 or 7 problems per night. But we were wrong because students got really addicted to it. They solved around 10 problems each night. So they get more land than we expected, and they get more money than we expected. And then it turns out we have inflation problem. So students keep complaining, wow, we have spent all our money buying, we bought all the monsters, but we still have a lot of money left. What can I do? So that's something we need to fix next time. We never thought that inflation was going to be a problem. Okay? And another thing very important is we have a ranking. That's a worldwide ranking. So based on the number of problems the students solve. So if you look at this, it's amazing. Like the top ranked students, they all solve up to more than 200 problems. More than 200 problems. And if you look at students' feedback, this course is offered in Chinese. So we have a lot of students that's Chinese student. But no worry, I'll translate it for you. Okay, this student said, it's been a great pleasure to come back dorm, solving problem sets right after my school time every day. So, well, this guy must be mad, must be crazy. But that's true, okay? Students enjoy solving problems a lot. And there's another student, he sent me the feedback, he said, with ParkMo, mom never has to worry about me not studying hard anymore, okay? So we found that we really get students addicted to learning, and we were really happy about it. And we are very interested on how this affects students' grade on Coursera. So basically, we classify the student into 3 different groups. Okay, low score group based on their performance on ParkMo. Low score group, middle score group, and high score group. And this is the Coursera grade, excluding the bonus point they will get from the game. So it's just purely performance in the Coursera homework and exercise. And this is a percentage of different scoring region. Okay, as you can see, the high score people in ParkMo, they do have the highest percentage of getting high score on Coursera. Okay, so you can see that the ParkMo score is highly correlated with their Coursera grades. Okay, so we think that this shows the evidence that students are really getting motivated to the Coursera course, Coursera homework by the gamification. Okay, and okay, so here we have some advice for the instructors if you want to try something like this. I think a very important thing is the reliability, because keep in mind that everything we build is going to be used by thousands of students. Okay, and you must know that, I don't know the case in the Western world, but in Chinese world, people care about fairness a lot. Okay, so if your system is not reliable and if your students suffer and getting some loss in their score, they get mad a lot. Okay, so reliability is very important. You have to do a lot of pressure tests before you launch your system. Another thing is that anything goes wrong, okay, we just honestly explain it to a student and try to fix it as soon as possible. Okay, don't try to cover it. If you want to try to cover it and student just tend to get mad really easily. So if anything goes wrong, just honestly explain to the student and tell them, well, this is a new system and we try really hard to give you a very special experience. A lot of the students can understand that and they will forgive us for having the problem. And the third thing is that if you want to try something in gamification, my suggestion is we have to always remember our purpose of teaching. Okay, it's all for the teaching. A lot of time we probably get over-designed for the game features, but that's not really our original purpose, okay? So, by the way, ParkMo is designed not just for probability course. It can be used for any course with closed-end answers, okay? And so if any professors or any instructor, if you are interested to have a gamification features for your Coursera course, we are very interested to work together to provide to launch more courses with ParkMo. Okay, so if you are interested, please feel free to let me know, and probably we can work together in the short future to enable your gaming feature on your course. Okay, thank you very much. Yeah.
Oh. I have a computer specialist here who's going to make sure everything works.
Am I playing it?
Go. I'm Jack Matson. What is this? What is this all about? How's it going to affect you? It will affect you, whether you like it or not. What's that all about? How does that fit into a MOOC? A MOOC on creativity, innovation, and change. That was my staff. Some of them weren't creative at all until we put them into the creativity machine. And this was workout. We worked out. The concept being that their minds needed to be warped. And what the word warp means, the dictionary definition is deviation from normal. Goal being wild mind, a natural mind, an open mind, open to possibilities, willing to take risks, willing to fail. And we did, we failed a lot because ours was a grand experiment. There wasn't a course like this taught by anyone in the world except me. But I taught it in the classroom where I could take people's brains and surgically change their neurons and synapses. How would that work with 150,000 people? That was the experiment. So we brought in the social media, Facebook, Twitter, LinkedIn, Google+. That didn't work very well. We tried experiments on these students. Like, what if you were given the task of making a bold act of defiance against society? What would you do? How would you do it? What is the meaning of it? Why are you defying society? Well, that's what innovation is in some respects. How much anxiety is there in doing that? These are difficult questions, difficult to deal with because we live in cultures where innovation is prized, but nonetheless we live most of the time in a status quo sort of situation. So to take people from where they are and move them, move their brains, move their minds, move their thinking into new areas was an enormous goal. And I'm going to leave it right there for your questions.
Thanks. Well, this is the time to make questions, comments, to share also your experiences. So, is there someone willing to ask something or make a question? Yes?
It's sadly very basic and it's for Rob. The drag and drop, was that done via an iframe or for the circuit board that appeared?
So say again?
The circuit board that appeared when they dragged the file.
Yeah.
Did you do that via an iframe or?
The great news on this one is that I have spectacular TAs. You know, if you bug me, if you go look on the website, it's actually on GitHub. You know, all of the sources out there. So I mean, there are some terrific modern JavaScript graphics libraries for these things. Yeah.
So this is open source. Everyone can use it.
Yeah.
Okay.
Yeah. I mean, the short takeaway is it's quite amazing what an amazing software platform a modern browser is. Right, and you don't even have to write everything at a very low angle, at a very low level of detail. Mostly, you can sort of reassemble other people's pieces. Oh, sorry.
Hi guys, thank you very much. So my question is more like, how much time, how much effort did you have to put to realize those framework? I mean, you said it probably is a different effort for the two classes, but how much time did you invest, or did you plan to invest to realize that?
You want to go first?
for all of them. Well, my class is more similar to the one of Rob or Benson, so like this is more like, but also how many people were involved in the process.
Like for my game, it was developed by 11 undergraduate students. Okay, but the problem is they are undergraduate students. So a lot of times they will say, oh, we have midterm exam, we have final exam, and they will just all disappear, okay? So project management is a big headache for me. So generally, actually the project started last year, right at the Coursera conference. We have a discussion with the R&D head of the Coursera to understand what kind of support we can get, and then it kicked off from that time, and it took us about 5 to 6 months to finish this whole system. Yeah, so it's like we have 11 undergraduate students working for 6 months to finish this system. Yep, thank you.
Roughly similar, just different age group. So I had 3 Illinois PhD students as teaching assistants. So 2 of them were from electrical engineering and they were doing the chip side stuff, and 1 of them was from computer science and he was doing all the platform, all the browser stuff. So 20 to 30 hours a week for about 4 months for all of us. So all of the comments you've heard in other sessions about it's really quite a remarkable amount of work to do one of these things is true the first time you do it. It's an enormous amount of work. I'm you know, as you watch me, I'm teaching VLSI CAD logic to layout right now, and I look much calmer than if you had caught me approximately. I was doing this in the middle of the last Coursera Partners Conference, and I was a much less calm individual. The second time you run it, it's vastly less anxious, right? Mostly you go back and you fix stuff.
We had a staff that varied from 5 to 10 people. We had a psychologist to make sure we didn't drive anybody insane in this process. We also had a theater arts professor who taught us the rudiments of acting. And that turned out to be tough because I didn't realize it. You have to write a script. You've got to edit it. You have to then memorize it and then say it on the big screen like you didn't memorize it. So these were all experiences, creative experiences we were having to go through. We also decided to have only 5-minute videos because that's now the attention span of college students, down from 15 a decade ago. So we tried to have short, snappy, to-the-point slides. It took us thousands of hours to do because it was a course from scratch and many thousands of dollars that we mostly had to raise ourselves.
Hi, Professor Matson.
Yes.
I understand you offered a class on those basically creativity, innovation, design. Is that what the class was about?
Say that again?
The class, the core topic of your class was creativity, innovation, and design?
No, and change.
And change.
And change. In other words, the strategy here is you come up with creative ideas, you try them out, you prototype, you fail a lot, and eventually, hopefully, you develop the knowledge from your failures to know what you're going to do. Well, you're going through a personal change in that process. You're changing yourself. And you got to be observant to the changes that you're making and understand that now you are bringing out unique characteristics that you haven't worked with before. So it's kind of scary as you see yourself becoming more and more of an innovator. There's personality change and things like that that goes with it. So that's why we had the change thing as an essential part of the course.
Do you think that you could also make social emotional skills as part of it, or was it actually already a big part of it? Social emotional.
Well, it's not only the social and emotional skills, because innovation is largely a team sport. But also, as you saw in the film, we wanted to bring in a whole body approach to it. So you saw a lot of physicality there in terms of what was going on. We just didn't want it to be a cognitive thing because that's not where a lot of your creativity is based. It's based in movement. And so how do you use your whole self to be creative and innovative? Like when I walked in this room and I looked around, I said, this is the worst possible case for having a discussion.
And we agree also.
And we got people pounding in the back and everything. Well, okay, how can I innovate on the spot and make it better? So that's why I'm down here in the audience, and in a few minutes I'm going to have you do something creative, but we're holding back on that for a few minutes. But the idea is that ultimately on the change thing is that you do change, and you change over where you're always looking for opportunities to be creative. And people, it scares them. So that's why we had our psychologists kind of say, oh, it's okay. You'll make it. Okay, other questions?
Hi. I was wondering if each of you could give a very brief example of an unexpected failure and an unexpected success in your course design.
Go ahead.
Oh, you got it.
Unexpected failure, I think. Okay. Well, our staff made a decision during the end of the course. They want, because there were some provinces that students still have the chance to do it. So they make some change on the on the rules so that people can do can do a lot of problems on the game, okay? But we thought that would be something that students really like because they get to see all the problem sets. But it turns out that it changed the ranking so much, okay? So a lot of people who ranked very high prior to the rule change, they are really mad about it. And they say, we no longer want to support your game anymore. We support your game for such a long time, now you change the rule, now we all fall back. So we had to honestly admit that we were wrong, and then we went back to the backup, the version of the previous 3 hours previously. So that was a bit failure for us, but we honestly explained our purpose, and the student forgive us at the end. Okay, that's unexpected failure, but it's caused by ourselves. And another thing is that unexpected success. I would say that although we did a lot of pressure tests, we still worry about the system not stable enough. So that night, when we launched our system, it actually is the same night I was invited to give a TED Talk in Taiwan. And we were so nervous about what things is going to be like. But thank God, nothing happened. The system went really smooth. So I wouldn't say it's an unexpected success, but I think that's something that really confirmed me enough. Yes, thank you.
Okay. Unexpected failure. Not precisely a failure, but we spent a lot of time in designing the software assignments so that they were approachable and were not ridiculously complex, and had really good auto graders so that the students got a lot of feedback. And in some sense, we made them, if you will, very approachable for the average student. Right. One of the things we didn't really quite anticipate was the number of students who, within 24 hours, submitted perfect software that passed all the regression tests. Bam! And then they looked at us and said, "That's it." Right. And so about halfway through the course, we ended up deciding to put very significant extra credit parts in the software assignments. And for us, mostly that meant, since we were actually having people doing sort of industrial strength designs, we gave them much bigger benchmarks that were much more complicated, and we asked them to do sort of a few additional steps toward a more realistic industrial strength design tool, and that made them incredibly happy, right? And so we didn't really anticipate the number of students who would want the maximally difficult experience. In the second running of the course, we've gone back and we've added harder parts to some of these things, which most of the class will never see, but a very small fraction, sort of the very smart, skinny end of the bell curve, will see and will appreciate us for. So that was an interesting one. Unexpected success. was remarkably surprised, again, this is a software-centric thing, remarkably surprised at the range of platforms and languages and things that people were using to do the software. So, you know, people write CAD tools in, you know, C and C++ and stuff like that, and, you know, and they do it in Linux. But there were crazy people in this class who were writing, you know, sort of very reasonable CAD tools in web scripting back-end languages. I had somebody write the first project in Ruby on Rails. That's nuts. That's insane, right? And then they started comparing, you know, the sort of the languages they did. And then I started talking with them on the forums, and it turned out that some of them were taking a programming languages course from some other universities and said, oh, this is an excellent example of a place I can use this stuff. Now, in the real world, you would never do stuff. You would never, ever do stuff like this. But they were having fun, and I was having fun. And I said, I can't believe you made that work. And they said, well, it worked. It's really slow, you know, and I'm not sure what will happen if you double the problem size. But, you know, it was, you know, this is a sort of getting to the creativity side of the world. You know, you give people a platform on which they can do something crazy. They did something crazy, and then it got infectious, and they started sharing it. And, you know, there was this nice little group of lunatics sort of sharing, you know, these programming languages. And it was fun, and it was completely unexpected.
I like that, lunatics.
Yeah.
We worked more toward insanity, and we had this concept called intelligent fast failure. The idea being that in order to be innovative, you're out there somewhere where there isn't any knowledge available, and you have to create your own knowledge, and you create it by trying experiments, trying them quickly, prototyping, and learning from those. So we had exercises that were impossible to do, where it was guaranteed failure because we wanted to have the students see that process work out. So we called one of the exercises crash and burn, or do something that you think is entirely impossible but you still wanted to do it. Go ahead and do it. See what happens. That's your class assignment. Please fail. Don't make it successful. Some people actually work the system so their failure was a success, but you know, they cheated. But anyways, we suffered a number of what I call slow, stupid failures. In it, I have just a short list here. We had set up a program called Teacher Hero for teachers who would blend the MOOC into their courses. And we signed up over 1,000 teacher heroes, and we had a nice program laid out for them, and we give them a nice certificate and everything like that. Well, when it was all said and done, 9 got certificates, 9 out of 1,000. Let's see, what's that percent? Not very good. The problem was we had so many issues running the course from week to week, we just didn't have time. We didn't have the resources to do it, so it was a slow and painful and stupid failure. So that's one of them. Another one was that we wanted to, at the end of the course, have the students who wanted to write about their experiences, between 2,000 words on what happened with them. And we got a lot of very good entries on that we thought that we would then put it into an ebook that would then become course material for the follow-on course. But again, it turned out to be an impossible thing for us to do given the resources we had. So we had to send everybody a message saying, I'm sorry, can't do it. But one of the people who had sent in one says, look, I'm starting this blog site just for this purpose, and you can post them up on the blog site. So that was a failure that, you know, took advantage of. I would say our success was that people hung in there with us. That is, this was an extremely difficult experiment to run, and running it for the first time, you know, it was ugly at times, it was great at times, it was emotional at times, and it was sad at times. But we were going through the motions that everybody was going through in the course. Some of the things were abysmal and others were great. But really we just had 3 messages in the course. One, everybody's creative. Their styles can be different, but you need to recognize you are and what your styles are. You need to organize yourself in a way to know how to take risk, and then the concept of intelligent fast failure. And I think they got it. We kept it simple. And the other thing was, of course, creativity. Everybody has a different definition of it. And so in that way, it was a connectivistic MOOC in that everybody participated in giving their ideas on creativity. And that made it kind of magical because we had all cultures. We had 195 countries represented. So that was all converging together on our website.
Hi, sorry. Question to Rob. Sorry. My name is Shimon Shokin. I work in a young small university in Israel called IDC Herzliya, and I'm now producing a course for Coursera on hardware design together with Noam Nissan from the Hebrew University. And two related questions. One, do you publish project solutions? And two, how do you deal with reusing problem sets from one generation to another?
Do we publish? Okay, so thank you. So do we? So the first question is, do we publish problem solutions? No. Primarily, that's just a survival mechanism because I want to run the MOOC a couple of times before I have to rebuild all of the problems. So one of the first things students ask is, can I get a hard copy of the problems, and are you going to give me copies of the solutions? And the first thing we say is no, because we have a bunch of we randomize the problems, and they have random parts, and we have a finite supply, right, of those things. And as soon as you have hard copies of the solutions out, someone is just going to go and be able to Google the solution. So it's one of the, I guess, least satisfying components of the MOOC, I think. Because if you take my class live, I give you a piece of paper that has the solutions for the homework assignment on it, and you get to go look at it. And if you take the course in the MOOC version, we do show the solutions, right? But you'd have to go print a PDF of the page or something. We don't show solutions for the for the software and stuff because we want to reuse it. I don't have anything very deep to say about reusing problems yet. I'm running it again the second time right now, and we'll see. We added some extra problems to the second run of the course. I think in an ideal universe, you'd go back into every assignment and you'd add a couple more problems, and then you'd sort of have by the time you ran it 4 or 5 times, you'd have a bigger pool of things. I have not redone any of the, well, that's not quite true. We made some small changes to some of the programs. So, what part of the formal verification assignment finds a bug in what part of what network, we changed where the bug was, things like that. So we'll see. These things are enormous amounts of work to put a good, it's an enormous amount of work to put a good software problem together, and even to put just sort of big, beefy homework problems together, but it's especially difficult to put big software problems together because you actually have to build a fairly serious suite of benchmarks, So, I mean, if you've done any, commercial software design, it's just like building a commercial regression test for, for like an enterprise class piece of software. You have to actually have a lot of little parts that you can grade, that you can tell people got it right, got it right, got it wrong, got it wrong, got it wrong, got it right, got it right. Zillions and zillions of little pieces, so they can get partial credit, so they can figure out where the errors are, because we don't have enough human resources to have people having face-to-face conversations.
Hi, I'm Shamrik. I'm from the National University of Singapore. I'm set up a course here which I'm going to do soon. Scary. I have 2 questions. So, when you did your extra stuff, was it on the Coursera servers or was it on your own servers?
So the extra credit stuff?
No, the gaming and the website. Both HTML5 stuff and your game was run on the Coursera server.
Okay. Well, actually, we built it on our servers. Okay, and actually we are moving it to the AWS in the future. So basically what you do is Coursera right now they have a support called LTI protocol. Okay, it enables your server to communicate with Coursera. So by using an LTI protocol, I can just simply add a button, like say ParkMo. When the student on the Coursera course page, when the student click on it, it is directly student are directly brought to the ParkMo gaming server. Okay, so it's seamlessly. You don't need to do the login action anymore. Okay, the LTI protocol directly send the Coursera ID to the gaming server, and the server will know which student comes in. Okay, and by the end of the game, okay, you can also use the LTI protocol to transfer the gaming score back to Coursera. Okay, so basically I just take a Coursera ID from Coursera, and then student, after they do things on the gaming server, I just send the score back to Coursera. Okay, so you can have an external server for these additional features.
So for mine, for the chip design thing, everything was done in Coursera, right? So that means that everything physically lives out in just, you know, Amazon EC2, the Elastic Cloud. And one of the things to just be aware of is that if you contact the sort of the Coursera technical folks, they will give you the exact specification for what that node is. I mean, it's running a particular version of Ubuntu Linux, and it's all this other stuff. And you can just go to Amazon, and your university, you can get a free node, with a little bit of time on it, and you can replicate identically for yourself what the Coursera node is. And so you and your TAs and anybody else, you can actually have access to sort of develop, and that's what we did, right? So we were building the software environment for the chip design course on exactly what the software environment looked like for a Coursera node. So we were very confident that when we moved it over to the course, it was the same thing. Because I'm just reemphasizing what, reliability, reliability, reliability. You can never test stuff that's going to have 20,000 simultaneous users too much, right? So we were very, very careful to make sure that anything we did, we did in exactly the software platform environment. So all of that web stuff you saw, I mean, that was, basically JavaScript and some, open source JavaScript libraries, right, that are basically being served from the Coursera, the Coursera platform. So all that web stuff and all of those other things, all that stuff is running directly in Coursera. We just decided as a design principle, we wanted it all on Coursera because then, I love you guys, it's your problem. Okay? Right, if the hardware or something goes down, if it's at the University of Illinois, it's my problem, right? Or it's Amazon's problem. I think we had the Amazon service went down for a couple of minutes once in the middle of the course, but the Coursera technical guys are spectacularly helpful on stuff like this. They're really, you can't say enough good things about the Coursera technical guys.
When Professor Benson, you showed a plot with 3 lines. What does the blue line mean?
So basically, there are 3 colors of lines, right? And I plot these different colors that represent different scoring groups in the ParkMo. Okay, so on the ParkMo score, they can get from 0 to 20, depending on their worldwide ranking. Okay, based on their worldwide rank, they'll get the score from ParkMo is 0 to 20. So we just observe 3 groups. One is I think it's 10 to 13, score 10 to 13, and 13 to 17, and 17 to 20. We observe these 3 scoring groups, and we plot the histogram of their Coursera grade. Okay, and we see that the green one, the one that has the highest score in the Coursera group, in the ParkMo group, they have the highest percentage of getting the high score in Coursera. Yeah.
The one that peak as well, right?
Yeah. Oh, you mean?
The blue one also peaked.
Oh, yeah. So everybody's doing well toward the high score in Coursera, but just that the percentage, like 90%, I think, I forgot the percentage, but probably 50 or 60% of the people who get good high score in ParkMo, they also got very high Coursera grade. Compare as opposed to the blue curve, probably only like 30% of them get high score at the but they all going up at the end. Yeah, that's right. Yeah. Thank you.
My name is Maria, and I'm at the American Museum of Natural History in New York City. And your comment just now, reliability is where this question comes from.
Yeah, okay.
For my course, because I'm using an external server, I'm using my own server. So that's why whatever change Coursera made, it doesn't affect me. So that's probably the benefit of having your own server. But then I have to take the full responsibility of the system going down. Yeah.
There's nothing like a PhD software engineering student. So I have a luxury that you probably don't have. We have not been bitten by that one yet. We just I mean, you know, we have all hands meetings for the TA staff, you know, every Saturday morning, you know, for the course, and we just talk about what's happening in the upcoming weeks, and we just sort of, you know, we test stuff. You know, I don't have a good answer to that one, other than you know, at the opening session, the new CEO said, you know, we're hoping to work better communicating with you. I recognize that was mostly policy, you know, and strategy kinds of stuff, but I think that you know, also as the platform sort of, you know, continues to get complicated and continues to mature, it's going to be the case that the technical guys, you know, probably could be giving people heads ups, you know, on some of these kinds of things. I mean, especially if there are some gotchas that you know, when I change X, lots of people get bitten because they assumed X. Right. I mean, that would be a good thing for the, you know, for a good takeaway for the Coursera guys would be, you know, what are the gotchas that people are, you know, people are building to rely on that are at a very low level that you're not thinking, you know, if I change this, it won't be that big a deal. I mean, all large platforms ultimately get some layer of insulation on top of them so that the deep, dark guts can be changed without zapping users. You know, I mean, this whole enterprise is only about 2 years old yet, so I guess I'm surprised it doesn't happen more often.
My name is Tammy. I'm from the University of New South Wales in Australia. I guess this is a question for all three panelists. I'm curious to know what your plans for course evaluation is, and what sort of instruments you intend to use or you have used to measure the effectiveness of your course design, and the results as well. So they sound like very innovative courses. Have they been successful in that sort of equation?
So you're talking about how to evaluate the course, the success, or?
Yeah.
Yeah.
So have you evaluated it, and what sort of instruments have you used to measure the effectiveness of your design? What are the results?
For my course, basically I'm using just we try to find a correlation of the students' performance in the game and with the Coursera grades. Okay, that's basically what we do at this point, and we hope that if we can see the high correlation between them, I think that to us we feel that that's kind of a success of showing that okay, students' behavior in the game does get them more engaged and thus gets better performance in Coursera. So that's basically what we are going toward at this point. Yeah.
Yeah. I mean, I'm running the course for the second time this time, and so I'm a little more sensitive to that than the first time. I think it's a completely fair statement to say that the first time you build a MOOC, you're just trying to survive, right? And so you're just sort of hanging on, trying to make sure that nothing goes boom, right, in front of 10,000 students. So. I mean, this sounds a little cynical, but just the fact that we got to the end of it with several thousand students having made it through all the homework assignments, and you know, I had 500 people take the final exam. I had several hundred people do the software. You know, I think that was pretty good. Mostly conventional survey instruments at this time. And I think we're having some conversations with Illinois has a very deep team of people just doing, you know, survey design stuff, you know, human factors kinds of stuff. I'm hoping to be able to work with those guys to figure out what a better, deeper set of instruments is. I mean, one of the things I did, which was quite satisfying, you know, on the final exam, I had a homework problem. I had a problem that actually had points associated with it, and the problem was, what else would you like me to do in this class? And it was just sort of a technical question. You know, it said I had to restrict the domain of coverage so that we could fit this in 10 weeks. What else would you like me to do? And amazingly enough, I got 500 thoughtful paragraphs, which were really amazing to read. And I built, you know, kind of a word cloud, and I showed it to people, and it was actually really interesting. So I mean, I got 500 people actually honestly telling me, I wish you could do more on X, I wish you could do more on Y. Right, now that's a very soft kind of an evaluation, but that does says that some fraction of them really thought this was an interesting experience and wanted to see some more. So I'm hoping to work more with the instructional design team for sort of more survey instrument kinds of things. I'm interested to know what other people are doing in this, in this universe. We're very open to good ideas here.
Okay, just briefly, since the course I taught is basically ungradable, we checked to see did you or did you not watch the videos on the exercises to submit reflections, and on the projects there were 4 steps on the project. So did they do all 4 steps? So it's more like in my mind a graduate seminar that grades are fairly irrelevant, but if you did do the course in terms of that was good enough. But in a course like this, most people didn't do that. A lot of people loved the videos and didn't necessarily want to do a project. We ended up only having 1,500 people do projects. We had 5,000 get certificates and about 14,000 that stayed there till the end. But hey, 14,000 in my whole career, I taught maybe 4,000 students, so it all works out. It's learning in its purest form. It's all voluntary, and you have to look at it that way.
We have time for one more question or comment, or someone wants to share something? No? No. 1, 2, okay. So.
Hi, my name is Julia Nielsen. I'm actually at the University of London here. I just wanted to find out what kind of support you felt you had from the kind of management at your institution about being innovative in your MOOC. Because I would think, especially when you were first doing it, a lot of institutions would say just doing a MOOC is kind of innovative enough here. We don't need you to spend extra resources making it extra good. And do you feel that's kind of changed now that we're a bit further along the kind of MOOC route?
Oh, I'll start out.
We can start out. You can go first.
Okay. We did have an instructional designer who tried to force us into holes that we didn't want to go, so we had interesting interactions there. We had some monies from the college, but it only covered about a quarter of what we needed. I think if I set what the total cost was, it was between $70,000 and $100,000, somewhere in that range. So we put on our fundraising hats, and we had one sponsor called BlackBerry, and they actually sent money before they went down. So we did do a fundraising thing, and that works because they become sponsors of the course, and it's good publicity for them, and we get the resources we need.
Yeah, I've got one. At Illinois, the management's been remarkably supportive. I mean, we haven't had any. I don't think anybody's gotten in the way of doing anything. I mean, we've had. We have had to exercise caution in some things. Lawyers get in the way on many of these kinds of things. One of the interesting problems is when you're taking other people's software and putting it out in the cloud, you actually have to read all the fine print in the license agreements, and then lawyers get very, very twitchy about that sort of stuff, and you have to basically buy them coffee and speak softly to them and say, it's okay, Google's not going to sue us. We did the first Android course, and there was a terrible fear on the part of our lawyers that Google was going to sue us. And I said, by putting the first Android MOOC together, I think Google is happy with us, actually. And so the university's been remarkably supportive of that kind of stuff. With respect to sort of cost and stuff like that, hasn't really gotten in the way yet. We've thrown, I don't know how many TAs, right, at these kinds of things. I mean, I guess the one thing that I will say, We have had conversations with some faculty who want to do a MOOC. This is going back to the reliability, concern, and have not thought through carefully enough the reliability issues associated with whatever software platform or platforms that they were going to do. And there's at least a moderate number of people at Illinois who are not real happy with me or some of the people in the back of the room who are smiling at me from the Illinois sort of team that has the ability to say no to someone's MOOC. And we sent a lot of those things back saying, how many people have you had using this software platform concurrently? I don't want to know that the answer is 70, right? I want to know that the answer is 17,000. Right, so that's mostly when things don't happen. It's because we have to tell people we're not sure yet it's going to scale, as seamlessly as you thought. Go back and think about this harder, and if you need to talk to some technical people, we can help you out on that.
Yeah. So you asked about the support, how the support we can get from administration. But currently, I'm the director of the NTU MOOC, so I'm the administrator. So that's a problem. I cannot put too much resource to myself on my own project. But another thing we are facing right now is because in Taiwan right now the economy is not that good. So actually the government is cutting the budget. So right now actually we already are facing budget cut for the course production. So we don't have that extra resource to support this kind of project. But fortunately, I think that in the IT industry, and also some venture capital companies, VC and some angel, they are very interested in this kind of thing. So maybe I think there's another way to get support. You can get support from VC and angel to convince them that this kind of system has some kind of, it can be promising in the future for the e-learning business or something. So you probably be able to get some support from the industry. Yeah, that's something I can think of at this point.
Are you doing the activity? No. Yes.
Okay. We're going
to we are about to finish, but now in order to be creative enough for the rest of the conference and to change ourselves, Jack is going to do an ontologic exercise, and we are going to leave this floor, this class
room. An ontologic, that's a hard, what does that mean, by the way? Okay, we'll go ontologic on this. What I would like for you to do is to stand up and with somebody in your row or whatever, make a human sculpture. A human sculpture, we'll show you, we'll demonstrate that here. Make a unique human structure. So, for example, you ready for the three of us?
Yes.
Okay, however you want to do it, make a unique human structure. All right, they're getting a little rough back here. Okay, let's see, a unique human structure. We need to see everybody with a unique, okay, that's good.
Take this, please, because I will not stand more than 1 minute.
Go forth and be creative. Thank you.